let's practice drawing one. You can work together. I know it's not really easy. My recommendation is, here's a marker that I know, right, is to, be like, okay, they're about 100 degrees apart. So you can kind of be like, I don't know why it doesn't start at some particular spot. It goes down to, 100 and draws number 1. So I would draw, okay, leucine, I would go find, first of all, is it nonpolar, polar charge? What is it? Nonpolar. Beautiful. And then I want to go 100 more degrees, and it's over here somewhere. And I would try literally drawing it out and then telling me where you think it would be located in a protein. So take a couple minutes, just a few. I think this is the last thing we'll do. Yes.
Why does the entire amino acid have a 100?
So within the helix itself, there are about 3.6 residues per turn. And of course, a full turn would be 360 degrees.
I understand that math, but I was wondering more like the bonding is
how the bond angles contribute. I'm not prepared to answer that, but I can get there. Yeah, exactly right. And that is part of why 3.6 exists in it, because of the length of everything is.
It just seems strange that there's no actual bonding in this.
Yeah, you're right. It almost certainly has to do with the bond between the N and the carbon and this one here are all in this approximately 1.5 range. So it's going to dictate how it would have to fit. There just literally wouldn't be more you could put in. That's a good point. Almost certainly you'll be asked to do this again on a homework or an exam, but I'll give you a diagram to draw in so that you do not. I'm no good at drawing.
You want us to draw the names?
No, however you want. So you can put if you want to put leucine here and whatever, but you want to color code them. Right now it's just for your sake. How would you fill these in and label them and decide where it would be? I mean, for me, I think it's easiest to label them as nonpolar or polar charge. The color coding and the sign of their polarity or charge is more useful for me to answer the question, just because I don't have memorized what's what. Oh, I'm looking at my answer and my colors are wrong. The answer's right. Who thinks they have an answer? Kara and Alex.
Yeah.
Antipathic.
Okay, so you're saying you think it's amphipathic, half is polar, half is not polar. So then the question asks which location, where would it be in the protein?
On the outside, on the side.
On the outside, okay. Kara, do you agree? Is that what you came up
I
with?
said mostly buried, or well, mostly buried with half like exposed.
If it's half and half, then we'll call it amphipathic. Right, exactly, like half looks like it needs to be buried and half looks like it needs to be exposed, so it's probably at the surface. Exactly, perfect. There it is. The colors are wrong. I do apologize. I do think this is negative, but these are positive and these are the polar that should be used to match the blue. I don't know what happened there. The important part is I can draw a line through this, separating my hydrophobic side and my hydrophilic side. And I can say more comfortably that I think this would be at the surface of a protein so that one side can interact with the outside and one side can interact with the inside. Okay? And so the reason this is important is because when we don't know every protein. And especially when there's changes in proteins that lead to disease and stuff, we need to figure out like what about it is different. So say we're able to isolate a protein sequence, now we want to figure out, okay, the very first time we're trying to define 3D structure to begin with, say we figure out the sequence because we've done some sort of DNA coding, right? We did DNA sequencing and we figured out what codons it would make and we get ourselves to this point. Now we want to draw the structure. Again, I don't know who wants this job, but somebody wants to figure out the structures of all these new proteins, and you can start seeing if it's going to make a helical wheel, and if it does, it's like, okay, hey, where might it be? Is it going to be on the outside, on the inside? And you can start to get yourself an idea of 3D structure going through this process.